All right, today we are doing chapter 2. It is linear relations and functions. So section 2-1 is relations and functions. So we've got some vocabulary to talk about. Some of it you should remember, some of it might be a bit new to you, and we'll just go from there. So a relation is a set of ordered pairs. So hopefully you remember an ordered pair looks like this, 1, 2, right? So that's your x, that's your y. 3, 4. These are ordered pairs, right? A function is a relation where each element of the domain is paired with exactly one element of the range. There's lots of different ways to explain that. So to determine if something is a function, we'll get to that down here in just a second, but we'll get to it in a second. A one-to-one function is also one-to-one like this, is where each element of the domain pairs to exactly one unique element of the range, and an onto function is where each element of the range corresponds to an element of the domain. So the differences in the types of functions can get a bit confusing. I'm going to show you a few examples, but the last time I checked, this wasn't necessarily in the standards anymore. So we're going to just kind of briefly touch on it, and then if you have more questions in class, we can go through that, or if it ever comes back in the standards, I will make sure to come back and circle back to this. So this is a function here. Again, there's lots of different ways to show that. With this one, you could rewrite it as your ordered pairs are 1, 4, 2, 5, and 3, 4. Your domain is this, and your range is that, right? So with these, this is a function because you could think of it as no x is repeating, and also our vertical line test down here too. So this is a function. With these are one-to-one, onto, and it's one-to-one and onto. I will explain these a bit more in class. This isn't something you have to try to figure out on your own. So we'll get to those in class if it's still a standard. If not, then we won't. So don't worry about that yet. You just need to know if it's a function or not. A discrete relation, the domain is a set of individual points. So a continuous relation, the domain has an infinite number of elements, a line or a curve. So let's show an example of a discrete relation. Here's our xy coordinate system. So a discrete relation looks like a bunch of points, as long as they're like this, right? Now a continuous relation would look something like this. It continues on and on forever in both directions, right? It could be a line, it could be a curve, something like that. So discrete, it could look like a scatter plot, and then a continuous is where it's basically a line, or it has arrows on both ends, probably would be a good way to say it. Vertical line test. If any vertical line, so vertical, remember, is up and down, it's a vertical line. If any vertical line hits the graph more than once, the graph is not a function. So for example, if I were to draw any vertical line here, it never touches the actual graph, the parabola right here, more than one time. This one does. Look, there's 2 right there, right? So that's not okay. That is not a function because it does not pass the vertical line test. Let's do a few more and see if you understand it. Is this a function? Yes, it is, right? No x's repeat. Let's do that. No, it's not, right? That is a vertical line, so it's not a function. Let's try this one. Yes? But what about this one? No, because these two, even though it's hard to draw, are on the same vertical line. Okay, super easy, super quick. The independent variable is usually the x, it's the domain. The dependent is usually the y, it's the range. And then function notation is f of x. F of x, you can usually replace it with a y. So if I ever gave you f of x equals, I don't know, x plus 2 or something, you could think of that for a little while as y equals x plus 2. These are the same thing. The f of x just already lets you know it's a function. You don't have to guess. Okay? On the back side, state the domain and range of each relation, then determine whether it's a function. If it is it one-to-one, onto, both, or neither? So with this one, what do you think the domain is? The domain is your x's, the range is your y's. So usually the way we write this is how I do it. There's lots of different ways to do it. It doesn't have to go in order necessarily, so I'm going to just go in order of the numbers I see. So negative 0.3. So we have domain is negative 0.3, we have 0.4, 1.2, and then typically you don't write it if it repeats. Technically you shouldn't. If you did, I probably wouldn't mark it wrong, but you don't need it there. The range is all the y values. If you want to be super proper, you do put it in ascending order, but again, I don't think that's a formal rule, so I'm just going to go in the order that I see for right now. So -6, -3, -1, and 4. Super easy. Domain, range, right? Domain is the x's, range is the y's. No big deal. Now let's see if it's a function or not. To go back, if something is a function, you have multiple ways to think of it. It has to pass the vertical line test, or if you want to think about it, if something does not pass the vertical line test, for example, this right here, right? This does not pass the vertical line test. This is like, I don't know, 2, 1, and this is like 2, -1. See how these have the same x value? That's why it doesn't pass the vertical line test. So if you want to go back to your vertical line test stuff and say no x's repeat, that's probably a good shortcut if it's given to you like that with an ordered pair or a t-table. No x's can repeat. Do any of these x's repeat? Yes, they do, right? Because of that, this is not a function. Okay? Let's try number 13. Because it's not a function, you don't specify what type because it wasn't one at all. On 13, take a minute, look it over. These are a few ordered pairs. You figure out what you think domain and range are, and then we'll go from there. The domain is all the x's, the -3, -1, 3, and 5. And the range is all the y's, so -4, 0, and 3. So now we have to determine if it's a function. Do any of the x values repeat? -3, -1, 3, and 5. No, they don't. So it is a function. Okay? We will go back and decide what kind of function it is later. I'll go back and explain those. That way, if it's not in the standards anymore, you can skip that part, okay? If it is in the standards, we'll talk about it. All right, graph each equation and determine domain and range. Determine whether it's a function. If it is, 1-to-1 onto both or neither, and then state whether it's discrete or continuous. That seems like a lot of information, so we really need to take it one thing at a time. Let's just start with the graph. That's what it says first, so let's do that first. What is this going to look like? This is going to be a line, right? This is y equals mx plus b, something you should remember. Okay? So slope-intercept form, so I'm going to start with my b, which is 2. So I'm going to go up 2 on the y-axis. And then this is my slope, which is really -3/1. So I'm going to go down 3 and right 1 from my y-intercept and graph this line. Okay? So we've graphed it. Determine domain and range. So our domain, this is a little hard to explain. So I'm just going to kind of jump into it and then be a little bit more specific in class, all right? Is there anything, when we're looking about domain and range, domain is your x's. These are all my x values, right? Going left and right. Do you see how these arrows, I know they go up and down, but do you see that they're still going left and they're still going right? There are no holes, there's no gaps, there's nothing weird here, right? You have an arrow going to the left for forever and up, and you have an arrow going to the right for forever and down. So what that means is your domain is all real numbers. You can write the words all real if you'd like, okay? But this is just kind of a fancy way to say all real. It's a double R. The same thing goes for our range here. See how this goes up for forever and down for forever? So every y value you could ever think of is going to be on our graph somewhere. So because there's no holes, what I mean is like if you had that, that's a hole, or a gap. So sometimes eventually we're going to get to a graph that looks like this. That's a gap, right? So because nothing weird happens, it's all real. Okay? The next question is it discrete or continuous? Well, let's remember what that means. So if you go back to the front, where was it at? Discrete. Is it a bunch of dots not connected? Or is it continuous where there's an infinite number of elements, it's a line or a curve? Which one do you think for here? Okay, so that's obviously a line because I kind of played around with it later, but it was a line, so that is continuous. That's pretty easy to understand, I think, for most people. This graph, number 17, y equals 2x squared, what shape is that going to make? That's a parabola, right? That's going to be a U shape. It's going to open up. We're going to have some tips and tricks on how to graph those a little bit quicker. If you really, really don't remember at all, you could always do a t-table. It's not the best, it's not the quickest, but it'll get you there for right now, okay? So if you plug in -1, 0, and 1, remember order of operations. If I plug in -1, that's y equals 2 -1 squared. You have to do exponents first. Well, -1 squared is just 1 times 2 is 2. So it's going to be -1, 2. If you plug a 0 in, 0 squared is 0, times 2 is still 0. If you plug a 1 in, 1 squared is 1, times 2 is 2. So we have -1, 2, 0, 0, and 1, 2. There's our parabola. Okay? So we've graphed the thing. Determine whether it's a function. Does this pass the vertical line test? Yeah, right? There's no x's that repeat. So yes, it's a function. I think we forgot to answer that over here. Whoopsie, we'll go back. So yes, it's a function. What kind? We will get to that later again. And then discrete or continuous. So is this a smooth curve with double-headed arrows, or is it a bunch of random dots? So that's going to be continuous, right? Domain and range. So again, this gets a little bit hard for a while, and we will keep working with it. Domain is all the x's. So we're thinking left and right, okay? Even though these arrows are going up, they're also going out at the same time. So if I go left and right, is there anything I'm not allowed to have? Are there any x's that have a hole or a gap or a jump? No, there's not. Okay, so again, an example of what would is if I had something weird like that there. Okay, so for right now, our domain is all real. Our range, if you look, this graph starts right here. Okay, what does range mean again? It means the y values, right? What ordered pair is right here? Isn't that 0, 0? Well, what y, because range, what y value is that? That's a 0, isn't it? So now my question is the graph above 0 on the y's, so up and down, or is it below? Well, it's obviously above, including 0. So I need that line underneath the greater than sign. If it was an open circle here, which doesn't happen very often in this class right now, but if it was, it would just be the greater than sign. Okay? I know that's kind of hard to wrap your mind around right now, and we will definitely get some more examples and work with it more in this chapter, so don't freak out too bad. Let's go ahead and do this bottom part, and we'll go back to the one-to-one onto and everything at the end. So this is totally different. This says find each value if f of x equals 3x plus 2, g of x equals -2x squared, and h of x equals -4x squared minus 2x plus 5. These are all given to you. You don't have to do anything, okay? So this is just saying f of -5. That means go to your f function, which is right here, and instead of f of x, this says f of -5. So what do you think you're going to put in instead of an x? -5. You're going to substitute, right? So my original function was f of x equals 3x plus 2. If I'm finding f of -5, I'm going to replace x with -5. Okay? For some people, it's confusing to write all that stuff, so you can just focus on this part if you want to. And then you do order of operations, calculator, whatever works for you. So obviously, that's -15 plus 2, which is -13. If you want to be super fancy, your actual answer is f of -5 is -13. Don't make that hard. It's just substitution, okay? H of 8 means go to your h function right here and plug in 8, right? So h of x, I like to rewrite it so I don't get confused and look at the wrong thing. H of x is -4x squared minus 2x plus 5. Okay, so all of the x's are going to be replaced with what? 8, because that's h of x. So I'm going to put an 8 here, and I'm going to put an 8 here. again, order of operations, this should be like second nature to you. You could probably plug the whole thing in if you really wanted to. You have to do the 8 squared first, and what's 8 squared? Right? So 64, so negative 4 times 64. What's negative 2 times 8? Obviously negative 16 plus 5. At this point, if you want to get your calculator out, that wouldn't be the worst thing. And go ahead and see what you get. You should get negative 267. If you don't, see me and I will let you know. So technically, h of 8 equals negative 267. Number 31, g of 3 halves. So for this one, again, you're going to use your g function, which is negative 2x squared. And instead of x, we're going to replace it with 3 over 2. I know you're tempted to use your calculator. You don't really need it yet, right? 3 over 2 squared is just going to be 9 over 4. Because 3 squared is 2, or excuse me, 3 squared is 9 and 2 squared is 4. And then you can obviously multiply by negative 2 over 1. You don't need help with that either. So you're going to end up with, you can write it any way you want. You can do, some calculators write it as an improper fraction, some do proper, it doesn't really matter. You end up with negative 4.5. So if you use a calculator, that's probably what you would get. If not, you would end up with, I guess you could do negative 18 over 4, which reduces to negative 9 over 2. And this is also negative 9 over 2. Those are all the same. It doesn't really matter how you do it. Okay? Take a minute, pause the video. If you have any questions, write them down, ask questions, get help, right? I know domain and range is hard. We're going to work on that some more in class. For now, I'm going to go back to explaining this a little bit better, a little bit slower. And if it's not in the standards anymore, we can skip it. I'll try to let you know. Okay. For a one-to-one function, let's say it again. Each element of the domain pairs exactly one unique element of the range. So this is one-to-one because each domain is going to one number in the range. Okay? So if I had added like this, that would not be one-to-one. And then if you look at onto, each element of the range has one element in the domain. So that's why this one's onto. See how each of these have one, at least one thing coming off of it? And then this one's both of them, where it has each of these are going to one thing over here, and each of these have one thing over here. So like this one is not onto, because see, this range doesn't have an element of the domain. I know that can be pretty confusing too. So again, if it's still a standard and we need to talk about it, I'm happy to do that in class tomorrow. Let me know what you need.